Okay, welcome back. Today we're going to talk about the common logarithm and the natural logarithm. So I'm going to try to pull this off. It's going to be a little more complicated because you're going to need to use a scientific calculator to do today's assignment. So I want to be able to you to see my scientific calculator while I'm taking notes as well. So we'll give this a try. So the first thing I want to talk about, what is the common logarithm? Well, the name basically tells you everything you know. The common logarithm is the most common logarithm that we use. And it's based off of our number system. Our number system is base 10. So the common logarithm is a logarithm that has base 10. Because it's the most common one, instead of writing when you have the common logarithm, instead of writing log base 10 of 100, another way you can write it is just log of 100. You can just leave the base 10 off. So if you don't see a base here, the base is actually 10, because this is the most common one. So this is the one that we use more often than the rest. So just to save some time and effort, mathematicians decided we're just going to leave that 10 off, since it's the most common one that we use. So these two statements, this expression here and this expression, are the same. It's log of 100, log base 10 of 100. So if you don't see a base, the base is 10. All right, so let's look at an example here. Well, because this is the most common one that we use, calculators have been designed to calculate logs of base 10. So we're going to be using a calculator today. So it says, use a calculator to evaluate each expression to the nearest tenth of 1,000. All right, so I want to find what is log base 10 of 120. I want to know what is log of 120. Well, if we did it the old way, we would have log base 10 of 120, and then we would set it equal to x. We would go 10 to the x power is equal to 120. And we would try to rewrite 120 as a power of 10. But you can't rewrite 120 as a power of 10. So what we're going to do, it's really simple. This is going to be one of the easiest assignments that you do. All you do is just type it into your calculator. So I'll have to figure out how this calculator works. Some calculators are different. So I'm going to type in 120, see what happens, and then hit the log button. Okay, so using this calculator, we're going to hit the log button first before we type in 120. All right, so what we're going to do is we're going to hit the log button, type in 120, hit equals, and the answer is, since we're rounding into 4 decimal places, instead of using equals, I'm using the approximation symbol, just like equal sign, like curves. So it's about 2.0792. So what that means is if you took 10 to the 2.0792, that would be about 120. And that does make sense. Because if you think about 10 squared is 100, and 10 to the third is 1,000. And 120 is in between 100 and 1,000. It's closer to 100. That's why our exponent is closer to the 2 up here than the 3 down here. And that's all we're doing today for this part of this section of the notes. So let's do B. I want to find what is log 0.12. Well, we'll just clear our calculator, hit the log button, type in 0.12, hit equals, and then round it to the nearest 4 decimal places. So B is about negative 0.9208. So this is what we're going to be doing today. So you are going to need to use a scientific calculator. For those virtual students, I'll have a link to the calculator I'm using. Actually, I just went to Google and typed in scientific calculator. So let's just finish these. So you might want to try C and D real quick to make sure you can get them, and then check them with mine. So type in log of 38.7, hit equals, round to 4 decimal places. Do log of 0.0041, hit equals, round to 4 decimal places. So if you did them correctly, here's what you should have got. 1.5877 for C. And for D, it's about negative 3.3872. Okay, let's move on here. All right, so if we read this paragraph, sometimes it says an application of a logarithm requires that you use the inverse of the logarithm, which is the exponential form. When you are given the logarithm of a number and asked to find the number, you are finding the anti-logarithm, it's called. So if we have a problem like this, log of x is equal to a, and we want to find x. Well, we did ones like this before. Remember, if you don't see a base, the base is 10. So what we did for problems like this in the past is we went 10 to the a power is equal to x. And whatever a was, we would just say 10 to that power. And that's your answer. Okay? So this 10 to the a power, another name for that is the anti-log. Okay? So I could have rewrote this as x is equal to the anti-log of a. That just means when you see the anti-log, you can think of that as your base. Your base is 10, 10 to the a power. 10 to the a power is the same as the anti-log of a. All right, so you can also use a calculator to do this. All right, so example 2 says use a scientific calculator to find the value of x. So again, remember, if you don't see a base, the base is 10. So there's a 10 there. So we would go 10 to the 3.073 power is equal to x. So basically, another way I could write that, x is equal to the anti-log of 3.073. Okay, whichever way you prefer. I think most students are going to prefer to leave it in exponential form. So how do you do this on a calculator? Well, let's see if I can see the whole calculator here. Let me move the screen over a little bit. All right, we want to take 10. I can't see the buttons here. Okay. So we're just going to clear our screen. We're going to type in 10. And what do we want to do with 10? We want to raise it to the 3.07 power. So I'm going to use this button right here, the x to the y power. I believe this will be the button that I use. So if I click on that button, see what happens. That makes it a little exponent. Now I'm just going to type in 3.073, and then it equals. And there's our answer. So our answer for part A would be x is equal to, now I want you to round to 4 decimal places, so 1,183.0416. And again, this is approximation. Instead of putting x equals, we can do x is approximately that. And remember, we were trying to find what is 10 to the 3.073 power. Well, 10 to the third power is 1,000, right? 10 to the fourth power would be 10,000. 3.073 is a lot closer to 3, so this answer should be a lot closer to 1,000. So it makes sense. All right, so let's try B. says log of x is equal to 3. This one you could actually do without your calculator. Because again, the base is 10. So you do the circle of life. 10 to the third power is equal to x. Or you can write it as x is equal to the anti-log of 3. So what is 10 to the third power? Oh, I just said it in the last one I was talking about. That's 1,000. So x is equal to 1,000. Alright, so let's do C together, and now I'll let you try to do D. It says log of x is equal to 2.5. So we're going to go 10 to the 2.5 power is equal to x. So what does x equal? So let's clear our answer. Type in 10, hit our x to the y power, type in 2.5, it equals. Around your 4 decimal places, so it's 316.2278. And again, when you see if I type in anti-log, that just means x is equal to 10 to the 0.5 power. So what does x equal on B? 10 to the 0.5 power is 3.1623. So that's common logarithm. You're going to be practicing that on your assignment today. You really don't need to show much work because the calculator does all the work for you. And now we have the common logarithm. Now another really common logarithm that's used a lot, this is more used in the science. It's called the natural logarithm. Okay? So this says, in much of science and mathematics, the number e is an irrational number whose approximate value is 2.718. Okay? It's used to model exponential growth. So they probably was using this when they were tracking like the COVID cases. So the number e, so you can do this on your calculator as well. There's a button that is located LN. That stands for the natural log. I don't know why they have it reversed. It should maybe be NL, but LN is the natural log. So if I had a problem like this, log base E of 2, another way I could rewrite that problem is to shorten it, because we use log base E a lot. Mathematicians shorten it to just Ln of 2. Ln of 2 means the natural log, it means the log base E of 2. Okay? So anytime your base is the number E, you can rewrite it as just Ln, and you don't have to write the base there. And one more important thing, this is very important. The natural log of E is 1. And the natural log of E is 1. The reason is, if you think about it the old way, well, this would be log base E of E. E to what power is E? E raised to what power is going to be E? 1. That's why the natural log of E is 1. We're going to see this a lot. So this is something you want to make sure you write down. The natural log of E is 1. Right, this is very similar. You do it the same styles as you did with the common logarithm. So I'm just going to show you how to do it on a calculator. Just like, let's see, did I skip over an example? Yeah, for some reason I didn't put some examples out. Let me look at the next screen. Oh, there it is. Let's see. All right, so example 1. It says, use a scientific calculator to find the natural log of 2.68. I'm doing example 1 here. The natural log of 2.68. Well, if this was the common log, we would hit the log button. Since it's the natural log, guess what? we just hit the LN button. So there's the LN button, we hit it, we type in 2.68, hit equals, there's our answer. So the natural log of the natural log of 2.68 is about 0.9858. It's that simple. Basically today, you're just getting practice using that calculator. So example 1, the second part. See if you can find the natural log of 0.045. So if you did it correctly, you should have got negative 3.1011. And again, to do it, you just clear off your screen on your calculator, hit the natural log button, type in what you want to take the natural log of, 0.045, hit equals, there's your answer. Just make sure you round correctly. Rounding to 4 decimal places. And just like the common logarithm had an anti-logarithm, the natural log does as well. Hopefully this calculator does it. I'll have to look at it. So if we have this problem, the natural log of x is equal to 0.75, and I want to solve for x. Well, let's think about this. This is a logarithm, my base, this is a natural log, my base is e. So what I would do is I would do e to the 0.75 power is equal to x. Or another way I can write that is x is equal to the anti-natural log of 0.75. That anti-natural log just means that's like your base, e raised to the 0.75 power. So does our calculator have the number e on it? Let's hope so. Let me see. Oops. Oh, right there it is. So we are going to go clear our answer at the e, and then we're going to just like we took 10 to a power, we're going to use this button right here. And then we would just type in 0.75. It equals. So let's go back to that screen, write this down. So A, the answer would be x is about 2.1170. So let's look at B. Let's set B up. Let's use our calculator to solve it. So B, we got the natural log of x is equal to 5.4. Find what x is about. So again, the base on this logarithm is e. So we want to go e to the 5.4 power is equal to x. And another way of writing that is the anti-natural log of 5.4 is equal to x. These mean the same. So go to your calculator. Let's take e to the 5.4 power and see what we get. It's really, today's assignment is just basically practice at using this calculator. So you're going to go e to the 5.4 power, which is about 22.4064. So B would be about, x is equal to about 1.4064. That's what you're going to be doing on today's assignment. There are some review problems also on today's assignment. But use your calculator on the common logarithms, the logarithms that have base 10, and then use your calculator on the natural logarithms, the logarithms that have base e.